Hello, BSCE2C. I am Maria Angelica Diligar, Isan, together with my co-reporters. We will be discussing you the structural geology and rock mechanics. But before proceeding to the discussion, let me summarize the topics na mapag-usapan natin regarding with this lesson. First is we are going to identify what is structural geology and what is rock mechanics. Next is the attitude of beds. We will be discussing the strike and dip. And after that, we will be discussing the outcrops. What is outcrops and how does it forms? Next, we have geological maps. It has three main types of geological mapping and three mapping techniques. And after discussing that, we will proceed to tackling the study of structures. It has three common types of geological structures. We will define also the importance of structural geology and its relationship to civil engineering. Of course, we are civil engineering students. Why do we need to study this and what is the connection of this sa ating course? And after that, we will talk about their bearing on engineering constructions. In this topic, mas mahihimay-himay natin kung ano ang fold, faults, and joints. And after that, meron tayong rock mechanics which has two branches, and we will talk about also the physical and mechanical properties of rocks such as porosity, permeability, density, strength, hardness, elasticity, and plasticity. And after that, we will discuss the dynamic properties of rocks and the methods in measuring its dynamics using field and lab or laboratory experimentations. And after that, we will also talk about the wave theory, and doon papasok yung factor influencing wave velocity. And the last topic that we will going to discuss in this lesson is this static and dynamics moduli of elasticity and grouting, such as grouting, grout, grout types, and grout materials. So let us proceed in discussing the structural geology and rock mechanics. First, what is structural geology? Okay, structural geology is use of measurements to understand the stress field that resulted in the observed strain and geometries. Dito, natin ma-identify at ma-understand yung structural evolution ng isang particular area due to plate tectonics. Such as, for example, yung mountain, building, rifting, and etc. So what is rock mechanics? Rock mechanics is a theoretical and applied science of a mechanical behavior ng rocks and rock masses. If i-compare natin sa geology, it is a branch of mechanics na concerned with the responses ng mga rock and rock masses sa mga force fields, and physical environments. So, let us now proceed to discussing the attitude of beds. So, what is the attitude of beds? It is the orientation or attitude of a bedding, one of the essential characteristics to gauge. Although sedimentary beds are typically deposited in horizontal layers, if the layers are not horizontal, of course, we can assume na meron ng tectonic forces na nangyari for them to cause to be tilted or folded. So, ang attitude of beds ay three-dimensional orientation or positioning ng isang given geological feature, such as bed, joint, fold, faults, and etc. So, meron tayong tinatawag na strike and dip. sa attitude of beds. What are these? Strike is the direction of the line that is formed by the intersection of the plane of the rock bed with the horizontal face. As you can see in the figure, yung line na to nagre-represent ng end ng seashore. So, yung strike can be measured for up to 0 to 360 degrees. So, let's talk about the dip. Dip is the direction in which the steepest angle is formed between the plane of the rock bed and the horizontal surface. So, as we can see in this figure, dip is the rock bed mismo, yung horizontal plane na ito, and naglalay siya sa horizontal direction through water. So, name-measure ito from 0 to 90 degrees. Next, let's talk about the outcrops. Outcrops is the visible exposures of bedrock or other geologic formations at the surface of the earth. When weathering and erosion reveal a portion of a rock stratum or formation, an outcrop is created. It is already said at the definition itself. It is how we see a bedrock through an earth surface. Kung paano yung formation niya. As you can see, mayroong mga ukit-ukit, yung parang sa mga falls. Nagkakaroon sila ng ganitong structures due to weathering and erosion. We can compare this to Banawe rice terraces, pero ang pinagkaiba lang nila, ang Banawe rice terraces is man-made while outcrops is natural, and yun nga, dala lang sila ng weathering and erosion.
Good day, engineers. I'm Joyce Oliva, and my report is about geological maps. A geological map is a special purpose map made to show geological features. Rock units or geologic strata are shown by color or symbols to indicate where they are exposed at the surface. Strike and dip or plunge symbols are used to depict bedding planes and structural elements such as faults and folds to provide three-dimensional features. Moreover, a geological map is actually used to interpret the structures and the historical record of the Earth's crust. It is our most important and complete compilation of information about the solid Earth we lived on. And hindi natin maiintindihan iyong Earth without a geological map. So in other words, or in simple words, geologic map show the geology of the surface of the Earth. And here are some facts about geological map. The first geologic map was first drawn by William Smith, and in 1801, he actually drew a rough sketch of what would become the first geologic map of most of Great Britain, and in 1815 he published it. So now, let's proceed to the main types of geological mapping. So the first one is topographic maps. Topographic map or topographic view using contour lines to show elevation. It shows a three-dimensional world in dimensions by using contour lines. So the second one is aerial maps. It shows a two-dimensional view of the location by using X and Y coordinates, maybe used for showing and comparing different aspects. So the third one is the Black's diagram. Actually, Black's diagram is not a map, but sometimes it is considered as a geological map because it shows data that is similar to a geological map. Now, sa mapping techniques naman tayo. So we have three mapping techniques naman. So the first one is traversing. We civil engineers are aware naman na siguro or may idea kung ano yung traversing. So traversing is walking along a predetermined route in the geology on the way. So next naman natin is line mapping. Green line mapping exposures range by green lines and gumagamit siya ng very fine very fine or 0.1 millimeter nib size. So yung pinakalas natin sa mapping technique ay iyong boundary mapping. It is one of the easiest methods of mapping where exposure is good, but it does not work well kapag poor ang exposure. So that's include my report. Thank you.
Study of structures. Branch of geology that focuses on how rocks change the shape in response to internal earth forces. Internal earth forces or endogenic forces, like earthquakes and volcanic activities. These activities causes impact to rocks that changes their physical properties. Common types of geologic structure. Faults are geologic structure that results from the bending and deformation of rocks. Faults form under varied conditions such as stress, pore pressure, and temperature. When we say pore pressure, it is the water flowing between the gaps of the rocks. Faults are geologic structure that results from the movement of rocks along a fracture or break in the Earth's crust. Fractures are commonly caused by stress exceeding the rock strength, resulting the rock to lose cohesion along its weakest plane. Moreover, plate tectonics such as convergent and transform fault causes the large faults. Joints are geologic structures that result from the cracking of rocks along planes of weakness without significant displacement of the rocks. Joints arise from fracture due to stress. Stress can be imposed outside. Joints are fractures on a rock without noticeable movements. It is also fractures with same orientation. Importance of structural geology. Important field because it helps understand the processes that shape the Earth's surface such as mountain building, faulting, and folding. Structural geology allows us to have enough knowledge about the processes that occurs within our Earth's surface. Relationship of structural geology and civil engineering. The characteristics of rocks and the forces that act on them are important for the design of structures such as bridges and buildings. As we can observe, rock is a primary material in building infrastructure, and as a civil engineer, we must guarantee the strength of our materials to ensure the safety of the people.
Their bearing on engineering construction. Significance of faults and joints in engineering constructions. Faults. Location of tunnels, quarrying, groundwater occurrence, laying roads and railways tracks along hill slopes, oil, gas, and ore deposits. Location of tunnels. Folded rocks are greatly strained the removal for tunneling because it can cause rock explosion. Along crest of folds, the rocks are in tension, therefore, they are highly unstable. In quarrying, better quality of rocks are available. Fractures associated with crest and scuffs are absent along the limbs, so quarrying should be done along the limbs. Groundwater occurrence. Synclines often furnish excellent conditions to tap groundwater. Artesian wells and springs originate from synclines. Fractures that are present can act as channels for groundwater movement. In laying roads and railway tracks along hill slopes, ground stability depends on the mutual relation of the depth of the beds and the slope of the cutting. If the surface slope and the dip are in opposite direction, the ground is stable. If the surface slope and dip collide, the ground becomes unstable. Oil, gas, and ore deposits. Oil and gas deposits are often associated with anticlines. Suitable cap rocks are also an essential requirement. Crest of folds offer convenient places for the occurrence of the deposits. Joints. Location of dams and reservoir. Occurrence of landslides, quarrying, tunneling. In location of dams and reservoir, Too many joints in a site will render it unsuitable for construction of dams. They act as avenues for serious leakage of water. Upstream dipping joints are less harmful. Kapag daw kasi madaming joints ang present sa isang site, nagiging unstable ang tunneling, pwede din magkaroon ng water leakage. Occurrence of landslides. Landslides take place when the surface slope of the hill and dip of the beds are in the same direction. Joints facilitate the heavy percolation of water. This water comes in contact with clayey material below the ground, producing fine lubricating materials which causes the slipping of overlying rocks. Quarrying. Depending on conditions, joints can play a helpful or harmful role in quarrying. Joints cut in situ rocks which can be easily extracted without the use of explosive. Too many joints, in the other hand, render quarrying useless due to excessive decay of rocks. Tunneling. Joints can severely hamper the strength of rocks. They may cause rocks to fall from the roof of the tunnel. Joints can cause the ground to be saturated with water, decreasing the strength of the rocks. They may act as sites for the development of solution cavities in limestone terrain. Faults. Location of tunnels, quarrying, roads and railway tracks along the slopes, groundwater occurrence, and ore minerals. Location of tunnels. Fault zones being heavily fractured makes the tunneling unstable. Groundwater-associated problems are likely to occur. Renewed faulting can lead to ground displacement. Quarrying. Quarrying in fault zones produce inferior quantitatively and qualitatively. Quarrying daw ay mas maganda ang quality at ang quantity around fault zones. Roads and railway tracks along the slopes. Fault zones are highly undesirable for construction of roads and railway due to the possibility of landslide. Groundwater occurrence. Fault zones being heavily fractured provides space for storage of groundwater and permits their movement. And lastly, ore materials. Fault zones are often rich in materials. They favor different processes that eventually lead to mineral formation.
It is that branch of mechanics that is concerned with the response of rock to the force fields of its physical environment. Rock mechanics is also concerned with the application of the principles of engineering mechanics to the design of structures built in or of rock. Rock differs from other materials in terms of physical and structural properties, like its tendency to weather with time. In relation to engineering, rock mechanics helps engineers to understand better how the rocks will respond to construction activities like tunneling and construction infrastructures. There are two branches of rock mechanics. First is structural rock mechanics. Structural rock mechanics is concerned with the stability of engineering structures in which material is predominantly rock. The strength of the rock can be impacted by temperature and moisture content. Usually stable structures can become unstable because it is in the damp conditions. Kaya crucial na tine-check yung mga moisture content ng bawat area bago magtayo ng isang structures. And mahalaga natin na test if stable muna yung isang structures bago siya buksan or patuloy nang gawin kasi maaaring makaharm ito sa tao. Kaya importante din na sina-check if stable yung isang structure sa any conditions or factors na maaaring maka-apekto dito dahil maaari itong makaharm sa tao na pwedeng pumunta dito. The second branch of rock mechanics is comminution. It is concerned with the reduction of rock into small fragments or particles by the application of external forces like grinding, blasting, cutting, and grinding. Comminution is also a breaking down process of any materials into small particles. A As you can see po sa picture, ito po yung example ng mga machines na nagbe-break lang ng mga rocks or any materials into small particles. And as you can see, rocks po yung ginagrind or kinakat into small particles. Rock mechanics is an important field to civil engineering as it applies to the majority of infrastructure projects like buildings, dams, bridges, tunnels, buildings, and protection of the slopes. So, mahalaga yung rock mechanics sa civil engineering kasi as I said earlier, ito yung nakakatulong sa mga engineers para maintindihan nilang mabuti kung paano magre-react yung mga rocks kapag ginamit na sila into building infrastructures. And dito din nila nalalaman if stable yung gagamitin nilang materials para hindi maapektuhan ng mga external factors na maaaring maging cause para maging unstable yung isang infrastructures.
I'm Abigail Mendoza from BSCE 2C and my report would be the physical and the mechanical properties of rocks. So continuing the report, physical property according to this is a characteristics of a substance that can be observed or measured without changing the identity of the substance. So, kapag pinag-uusapan daw natin yung physical properties ng isang material o ng isang rock, wala tayong binabago sa kanya or wala tayong major changes na ginagawa sa isang material or sa isang rock. Pwede nating baguhin or the physical properties only includes changing the color, changing the shape, the volume, the density, the temperature, and its boiling point, but it is still the same. And mechanical properties naman, they are defined as those properties that influence the material's reaction to applied loads. So, kapag pinag-uusapan natin yung mechanical properties, papasok dito yung response ng rock kapag nilagyan natin siya ng loads or pressure or applied temperature. Dito natin masusukat sa mechanical properties yung functionality ng isang material, yung stiffness niya, yung toughness of a material, strength of a material, its ductility, hardness, and the impact's resistance. Dito natin yun ma-identify at ma-determine. So, porosity. Porosity is an example of the physical and mechanical properties of rock. Ito yung number 1. And it is connected with permeability. So, the meaning of porosity is, it is a measure of the void spaces in a material. They are related to permeability in properties of rocks. At kapag pinag-uusapan natin yung porosity, these are the spaces between the particles of a rock. So, kapag kasi tinignan natin yung isang rock, makikita natin na solid siya, but under lens or under a microscopic lens, makikita natin na there are still spaces. Magkakadikit sila, however, they still have this what we call void spaces. So, yun yung pinag-uusapan kapag porosity, the void spaces. Example nito yung sponge. Kapag nakita natin yung sponge, it is a solid. However, if we look closely to it, meron tong mga spaces or mga butas. Those are the void spaces. The next one is the permeability. So, according to this, permeability is a measure of how interconnected the individual pore spaces are in a rock or a sediment. So, makikita natin sa picture. Although buo yung rock, pero tatagos pa rin dun yung water. That is what we call permeability. It is the way that the fluid flows in the void spaces that we have called porosity. So, kapag sinabi natin permeability, the way that the fluid flows between the spaces of these grain or pores and rock, in the rock. So, the next one is density. Density, kapag define natin siya, it is the mass per volume. And there are 3 types of density in rocks, namely the dry density, the wet density, and the grain density. So, density is very important for us because it allows us to determine which object or which substance or rock will sink or float in the water. So, yung density, siya yung ginagamit natin para ma-identify kung yung isang bagay daw ba ay lulutang sa tubig or lulubog siya. So, hindi dito pinag-uusapan yung properties niya. However, dito natin malalaman if lulutang nga ba siya dito sinasabi nating water. So, yung density natin, meron under siya sa tatlo. The dry density, the wet density, and the grain density. So, the meaning of the dry density is measured on rocks without any water or fluid in their pores. So, kapag doon pinag-uusapan natin yung dry density, yung pag-measure natin, hindi siya nag-i-involve ng water or fluid. Talagang pure na solid lang siya as in dry. At hindi natin i-involve yung water or yung fluid na sinasabi nga natin sa pagitan ng void spaces niya. The next one is wet density. Kapag wet density naman, it is measured on fully saturated cores. And lastly, yung ating grain density. When we say grain density, we describe this as the density of solid or mineral grains of the rock. So that is all my part, and the next reporter will continue the reporting. Thank you.
Hi, I'm here to talk about the physical and mechanical properties of a rock, and I hope that you will learn some. So, properties are all these characteristics describe or helps us to describe the substance of a material. So, let me explain first the word physical and mechanical properties are the important parameters used to determine the performance of a rock. So, let me explain first what is strength. The strength of a rock is defined as the resistance to permanent deformation by flow or fracture. The strength of a rock is a very important physical properties for defining failure in engineering design. Kasi sinusukat ng strength of a rock kung gaano ba kadaming energy yung kaya niyang i-absorb up until fracture. These properties of strength is usually ginagamit sa mga building or infrastructure para malaman kung gaano kaya i-resist ng rock yung bigat ng isang object or material na ilalagay sa building para maiwasan yung pagguho or pagkasira ng isang building. Next is that we have a texture or hardness. So when we hear the word hardness, it is a measure of its relative resistance to scratch. The hardness of a rock is measured by how much it resists the substance being pushed or hindi agad-agad masisira ng simpleng scratch lamang yung isang object. Kasi this properties is usually ginagamit natin to cut or slice an object harder than that property. Or usually, ito yung ginagamit ng mga sinaunang panahon or 100 years ago to cut or slice an object kasi wala pa namang naiimbentong sharper object that time. Therefore, yung hardness ng isang stone yung ginagamit nila to slice an object. And based sa na-research ko, ang hardest known substance is diamond. And the hardness of a diamond can just literally cut a glass or simply by scratching the glass using a diamond is mapuputol na or mahihiwa na yung glass. Another is that the elasticity. Elasticity naman is nangyayari siya kapag yung shape ng isang object or material ay nagbabago and mababalik siya sa pinaka-original shape niya even wala ng force na nag-a-act. Like for example, itong rubber, hinila ko to. And then yung pagkakahila ko na to is merong force dito sa pagkakahila ko na to na ina-apply. And once na yung pagkakahila ko na to is tinanggal ko, wala nang force na mag-a-act. Even walang force na nag-a-act dito, yung rubber band na to is bumalik pa rin siya sa original shape niya and hindi siya naputol. Kaya, yun yung tinatawag na elastic. Another is that plasticity. Plasticity naman is defined as the changeability or moldability, or it is the ability of certain solid to flow or to change permanently. This process is called the plastic deformation nga, or it is not necessary of the object to break or hindi masisira ng ganun-ganun yung object. Like, for example, dito is yung steel string. Example ng plasticity is steel string. Yung steel string kasi, kapag hinila mo siya, or nag-apply ka ng force doon sa steel string, kahit gaano pa kadaming force, or gaano pa kalayo, or dami yung i-apply mo ng force kapag hinila mo yon, once na ibinitawan mo yon, is ganun pa rin yung, or mabilis pa rin siyang babalik sa original shape niya, kaya tinatawag siya na plasticity. And the more resistance it needs, the more elastic it is. Kaya naman, yung steel string kasi is nangangailangan siya ng more force and more resistance nga yung steel string compare sa rubber string. Kaya naman, yung steel string na example natin is the best example for plasticity. Kasi, kahit na gano kalayo pa yung hila na gawin natin sa steel string and gano kadaming force yung i-apply natin, mabilis pa rin siyang babalik sa original shape niya compare sa rubber string na kapag hinila mo siya or nag-apply ka ng maraming force is magkakaroon siya ng farther distance, and once na tinanggal mo yung force na yun is babalik siya sa original shape niya. Pero if i-compare natin si steel string is mas mabilis nga lang yung pagkakabalik ni steel string compare kay rubber string. And dito nga, yun nga yung tinatawag natin na plastic deformation, yung process na yun, or yun yung nangyayari or tinatawag natin na plasticity. Kasi the more na resistance it needs, the more elastic it is. Therefore, permanent change of shape of an object happens more quickly dito kay plasticity.
Next, let's talk about the dynamic properties of rocks. So let's define. The dynamic property of rocks is geotechnical engineering applications such as seismic design, foundation analysis, and slope stability depend on the dynamic properties of rocks such as modulus, damping, and wave velocity. So dynamic properties is important for geotechnical engineers kasi application yon ng mga, yun nga, seismic design, foundation analysis, and slope stability. But, of course, measuring these properties in the field or in the lab can be sometimes challenging due to the heterogeneity, anisotropy, and nonlinearity or pagkakaiba-iba ng mga rocks. But we have methods to measure dynamic properties of rock in the field and in the lab. So, first is the field methods. It includes subjecting the rock mass or structures to dynamic loads or vibrations and measuring their reactions such as displacement, stresses, and accelerations that are produced. Seismic refraction, seismic reflection, spectral analysis of surface waves, cross-hole and down-hole testing, and dynamic penetration tests are few of the frequently used field techniques. So, this method can provide us information on the wave velocities, layer thickness, elastic moduli, and damping ratios ng rock mass. But field methods also have some drawbacks, of course, due to the influence of environmental noise, need ng mga large test areas, and minsan may mga difficulty of interpreting complex wave phenomena. So next is the lab method. With lab approaches, rock samples are examined in a regulated setting using specialized tools and procedures. Resonant column tests, cyclic triaxial testing, bending element tests, ultrasonic tests, and dynamic shear modulus tests are few of the frequently used laboratory techniques. So, this method naman can provide us accurate and more reliable measurement ng dynamic properties of rock by modulus, damping, strength, and strain-dependent behavior. However, lab methods also have some limitations, of course, such as the representativeness of the sample, the scaling effects, the sample preparation and handling, and the cost and availability ng mga equipment na gagamitin natin to measure dynamic properties of rocks by means of lab methods. Next is the comparison and selection. The appropriate approach depends on a number of aspects, including the goal and scope of the study, the availability and caliber of the data, the budget and time restrictions, and the desired level of accuracy and reliability. Both field and lab procedures have advantages and disadvantages, of course. So in general, field methods are more suitable for large-scale and site-specific investigations while ang mga lab methods naman are suitable lang for small-scale and material-specific investigation. But of course, combination ng field and lab methods can often provide a more comprehensive and robust understanding of the dynamic properties of rocks. Next is the data analysis and interpretation. To determine the dynamic properties of rocks, data from field or laboratory methods must be examined and interpreted. Curve fitting, frequency domain analysis, wave propagation modeling, inverse analysis, and statistical analysis are some examples of the approaches that may be used for this. So it's like thesis, merong data analysis and interpretation, whereas it has to be more clear and understandable. This can involve various techniques such as yun nga yung mga curve fitting, frequency domain analysis, wave propagation modeling, inverse analysis, and statistical analysis. Etong techniques na to can help us to identify the dominant modes ng vibration, dispersion, and attenuation characteristics, the elastic and inelastic behavior, the uncertainty and variability ng mga properties. However, these techniques also require us to be more careful in selection of the parameters, assumptions, models, and critical evaluation of the results. Parang katulad lang talaga siya ng thesis na kailangan ng critical thinking for us to be more clear sa pag-understand ng data at interpretation para mas maging reliable yung maibigay nating result. Last is the application and implication. Many geotechnical engineering applications, including seismic design, foundation analysis, slope stability, tunneling, blasting, and rock mechanics, depend on the dynamic properties of rocks. So this application naman requires a good understanding of how rock respond to the dynamic loads or vibrations, and paano nakaka-affect ang performance and safety ng structures and systems. Therefore, measuring the dynamic properties of rocks using best methods can help us also can help us, of course, to improve the design, construction, monitoring, and maintenance of this application. Next, we are going to talk about the type of wave theory to be discussed by John Benedict.
Types of wave theory. First one is the body waves. Body waves travel through the interior of the Earth. Body waves are relatively low amplitude, impulsive signals that are teleseismic distances, propagate along a variety of paths through the deep mantle and core. There are two types of body waves. The first one is the P waves. The PNP wave stands for primary because these are the fastest seismic waves and are the first to be detected once an earthquake has occurred. P waves travel through the Earth's interior many times faster than the speed of a jet airplane, taking only a few minutes to travel across the Earth. P waves are predominantly compressional waves as P wave passes, material compresses in the same direction. The wave is moving and then extends back to its original thickness. Once the wave has passed, the speed at which P waves travel through material is determined by rigidity, compressibility, and density. First, the rigidity. Rigidity is how strongly the materials resist being bent sideways and is able to straighten itself out once the shearing force has passed. Compressibility. How much the material can be compressed into a smaller volume and then recover its previous volume once the compressing force has passed. The more compressible the material, the faster the P waves. The third one is density. Density is how much mass the material contains in a unit of volume. The greater the density, the slower the P waves. The second type of body waves is the S waves. The S in S wave stands for secondary because they are the second fastest seismic waves and the second type to be detected once an earthquake occurred. Although S waves are slower than P waves, they still travel fast, over half the speed of P waves, moving at thousands of kilometers per hour to the Earth's crust and mantle. The speed at which S waves travel through material is determined by rigidity. As I've said earlier, rigidity is how strongly material resists after being bent sideways and is able to straighten itself once the shearing force has passed. And then density, how much mass the material contains in a unit of volume. And the greater the density, the slower the S waves. Because the Earth's mantle becomes more rigid as its depth below the asthenosphere increases, S waves travel faster as they go deeper in the mantle. The density of the mantle also increases at greater pitch, which has the effect of reducing the speed of seismic waves. But the increase in rigidity is much greater than increase in density, so S waves speeds up as they get deeper in the mantle in spite of increased density. And same as the P waves travel faster as they go deeper in the mantle because the density of the mantle is also increases with the depth below the asthenosphere. The higher density reduces the speed of seismic waves. However, the effects of increased rigidity and compressibility in the mantle are much greater than the effect of the increased density. The second type of wave theory is the surface waves. What is surface waves? Surface waves refers to disturbances or waves that travels on bodies' surfaces. They are considered to be a combination of both longitudinal and transverse waves. There are two types of surface waves. These are the Rayleigh waves and lava waves. The first type is the Rayleigh waves. Rayleigh waves is a type of surface wave that moves the particles of the medium in both vertical and horizontal directions along the vertical surface. Rayleigh waves are named after the British physicist who was the first to demonstrate the existence of Rayleigh waves mathematically, and he is Lord Rayleigh. A second type of surface waves is the lava waves. Lava waves are the surface waves that move the medium's particles along the horizontal plane in the perpendicular direction of the wave propagation. Lava waves compared to Rayleigh waves, the lava waves yield considerable amount of pressure on object on the surface, such as tall buildings, by damaging the structure's foundation. And here are the 5 examples of real-life example of surface waves. The first one is water waves. Water waves is when, for example, when you throw a stone in the water, you might probably notice that ripples form in the water surface. Another instance rather, is when diving into a body of water, like a pool or the ocean, causes this ripple to appear. These ripples are known as the water waves and occur due to disturbances caused on a still water surface, which travels from one point to another. The second one is seismic waves. Seismic waves are caused by sudden movement of Earth's tectonic plates. They are a perfect example of surface waves because they exist on Earth's surface and not inside the core. The third example is gravity waves. We all know that gravity is the force that holds object in place. Is responsible for is responsible for them from falling. This type of waves occur within liquids and the surface of fluids. The fourth example is the wind waves. Wind waves are un- Wind waves undertake the task of generating or forming surface waves. If you see a large surfing waves on the ocean or sea, winds are what is responsible for it. This is because that the wind that blows on the surface of the ocean tends to travel in the opposite direction. The last one is the electromagnetic waves. Some electromagnetic waves functions just like surface waves. This can be seen when electromagnetic waves like radio waves propagate along the surface of the earth to communicate or exchange information between 2 points. Factors affecting wave velocity. The first one is wavelength. Wavelength is the measure of the length of a complete wave cycle. The velocity of a wave is the distance traveled by a point on the wave. In general, for any wave, the relation between velocity and wavelength is proportionate. It is expressed through the wave velocity. Second one is frequency. An increase in frequency will increase the velocity of the wave. That's how it influences the wave velocity. The third one is medium. Medium is the density of the surface. The higher the density, the slower the wave. And the last one is temperature. Temperature is the speed of wave increases. As the temperature increases, this is due to increased kinetic energy of their molecule and decrease in density. And that concludes my part. On to the next presenter, please.
Guys, I am Ferry Yamawi Viandes. Ang re-report ko is static and dynamic moduli of elasticity grouting. Static and dynamic moduli of elasticity grouting. Grouting in civil engineering refers to the injection of pumpable materials into a soil or rock formation to change its physical characteristic. It is one of the ways groundwater can be controlled during civil engineering works. Grout. Grout is composite material used in construction to fill voids and seal openings in surfaces. Or grout can be defined as a solution, an emulsion or suspension in water, which will harden after a certain time interval. It can be divided into two main groups. Group type, Group types: suspension grout. In a mixture of one of several materials like cement, clay, etc., suspended in fluid water. Liquid grout or solution grout consists of chemical products in a solution or an emulsion from their reagents. And grouting materials. Cement-based grout are the most frequently used in both water stopping and strengthening treatment. Pure cement grout. It is unstable grout, however, bleeding can avoid with water cement ratio less than 0.67. Usually mixed proportion are from water cement ratio 0.4 to 1:4 grouting. Bentonite grout. It is a stable grout when bentonite is added to cement suspension. Grout wheel fillers. Grout wheel fillers are added in order to modify the viscosity of given grout so as obtain a low-cost product to substitute the cement. Silicate-based grout are sodium silicate in liquid from diluted and containing reagents. Soft gel Soft gels. It is a mainly for water stopping purpose. They are gels with a very low dosage in silicate in which the gelling process is most generally obtained by adding mineral agents. So that concludes our topic that the rest of my co-reporters are hoping that you have learned from us. Thank you for watching. Bye-bye.